As a small business, I have multiple users that interact with my AWS accounts. This includes a website editor, a DevOps engineer, and an occasional contractor too that perform ad hoc tasks. With different users coming and going at different times, it's difficult for me to get a centralized view of who has permissions to what. Often I find myself manually creating new users, cleaning up old ones, and adding custom permissions on a use case by use case basis across different AWS accounts. This problem gets amplified if you're like me and have many different AWS accounts that all have a different purpose. IAC solutions like CDK or Terraform can help, but they don't work very well with cross-account management and don't let me define temporary permissions. What I need is something that helps me manage user profiles and helps me give access to only what users need and nothing else on specific AWS accounts. I'd like to introduce you to Iambic. Iambic is a multi-cloud identity and access management control plane that gives you visibility and history of how your access and permissions are changing over time. It also simplifies access and permissions management across your cloud environment. In about 10 minutes, I was able to import my existing AWS configuration, including users and roles, start creating new ones, and modifying existing ones through template files. And just like that, I had a 360-degree view of my entire IAM setup across all of my accounts. It just works. No more manually clicking around the console and trying to find out who has permissions to what. And no more worrying about forgetting to delete a user after they've finished their work with me. It's easy to use Iambic to expire credentials at predetermined times in the future. Now, Iambic doesn't need to manage all of my IAM. I can still use things like Terraform, CDK, or Pulumi, or if I get lazy, I can even click around in the console to make permission changes. Iambic will keep track of all of those changes and write them into version control, giving me an updated source of truth regardless of how changes are happening. If I want to protect a sensitive policy from being changed, I can use Iambic's drift prevention feature so that any IAM changes made outside of it are automatically detected and reverted. It's almost like having a security engineer watching over my shoulder. I'm even able to provide users with permissions that span multiple AWS accounts, all in a single Iambic file. No more creating policies with different permissions on each account for the same user. And on top of that, by integrating Iambic with GitHub for source control, I'm able to get a full audit trail of how my permissions change over time. I can automatically expire access to accounts, roles, or policies. This makes it easier for me to track down overly permissive policies, remove access that isn't needed anymore, and keep my permissions sparkly clean. Now, while this is an AWS channel and I've been talking a lot about Iambic's AWS support, it also works with Azure Active Directory, Okta, and Google Workspaces. So regardless of which identity provider you're using, you can easily integrate your user base into Iambic and manage their permissions dynamically. Iambic will import all your human users, applications, groups, and permissions from your identity provider right into source control, all in a consistent format. No more logging into multiple consoles trying to make sense of my environment. It's all in one place and always up to date. And the best part? Iambic is completely free, and the source code is publicly available on GitHub for you to take a look at. So let's get Iambic set up right now. I'll walk you through every step to get it going locally. After that, we'll do a quick demo before popping the hood on this baby to understand how it works behind the scenes. But before that, I'd like to thank Iambic for being the sponsor of this video. Those of you that have watched this channel for a while know that I'm very particular with the products that I feature. But Iambic checks all the boxes and I just love it. So with all of that out of the way, let's get started with setting up the Iambic CLI. All right, so first things first, we're going to be creating our virtual environment here using this command. After doing that, a new directory will be created. We're just going to go ahead and activate our environment now. And at this point, we are ready to install the Iambic core CLI. We're going to be using this command here, pip install Iambic core. You can see here that after a brief moment, everything got installed successfully. I'm just going to briefly type the Iambic command to verify that everything is working correctly, and you can see some of the different commands that are available at our disposal. We're going to be using the Iambic setup command to import our existing resources into our repository. First, it's asking us which identity we'd like to use, so obviously we're going to select AWS here. Now we select the region, US East 1 for me. Now the wizard is asking us which account ID will contain the hub role. In Iambic, the top level account used for administration is called the hub, and child accounts are called the spokes. Iambic will create roles in each respective account to manage your permissions for you. Now, if you're using AWS organizations like IAM, your account ID will be the management account of your organization, so we'll put that in here. This is also probably the right time to mention that you will need to have your AWS CLI configured with an administration role for your management account, which I've already gone ahead and done. We confirm the identity to use for the setup, and then select AWS organizations for configuration. We once again confirm our account, and then verify our organization ID. We will be using our default AWS CLI profile, and next we confirm Iambic to have write access to our accounts. We confirm the identity, skip the optional step, and then we confirm that we're okay with Iambic creating the required roles for us via CloudFormation. Now we just wait until the required stacks and roles are configured. We skip setting up SSO, and then finally we're asked whether you'd like to import the existing AWS identities into your project. I'll select yes here. At this point, Iambic is scanning our organization's users, roles, and policies to build a project structure that reflects our setup. Finally, we confirm that we're done, and we're now ready to review the template files that Iambic generated for us. Now, after running Iambic setup and importing our identities, we're left with a detailed project structure that reflects the setup of our account. If we take a look at this file at the top level, this is an Iambic template file. Within this particular one, we can see details of the different AWS accounts that were imported, including their names, account IDs, the organization they belong to, along with some other details. Something worth noting here is the account name field, which automatically gets set to the name of the account within the organization. We'll be using this field a little later when we create policies and users. Now, if we expand the resources directory, we can see more of what Iambic imported. For example, here's a file in the group directory that shows a simple test group I created earlier. Within role, you can see some AWS service roles that were brought in by default. And within user, you can see some pre-existing temporary users within a folder that corresponds to the account name that they belong to. This folder structure is Iambic's default effort to organize all of your resources. You can refine it to your liking, but this is what you get out of the box. So that's a review of the structure after initial setup. Let's get started creating some policies and users using Iambic. To understand that, let's briefly take a look at the end goal that we're aiming for. I find that it's best to understand where we're going before we learn how to get there, and this case is no exception. This diagram reflects our end goal. At the top, we have our AWS organization with two AWS accounts, the first being for website purposes and the second used by contractors. For my website account, I have a Lightsail instance that hosts my website, and I'd like to give James, my website editor, an account and the right policies to control it. For my contractor account, I typically let users interact with AWS Lambda and DynamoDB. In this case, I like to set up a user account for Adriano that has these two permissions. Finally, I have Emily. Emily is my DevOps person that keeps an eye on both accounts. I want her to have CloudWatch access to both the website and the contractor account. So this is the goal. To get there, we're going to continue using the Iambic CLI. We've already completed the setup and import steps, and now we just need to create the templates and then run the plan and apply commands to deploy our changes. So let's get started. To get started, let's first create the policies that we'll need. We'll go under the Managed Policies subdirectory and create a new folder called Custom Policies. We're going to create 3 different policy documents now, one for our website user, another for our contractor, and the final one for DevOps. Now that we have the files created, let's fill in our policy document starting with the website policy. Dropping in the policy here, you'll notice up top under Included Accounts, we're referring to website. In Iambic, this means that this policy will be created just in our website account. Below it, we have our standard CloudFormation-like syntax for creating a policy. This one grants all Lightsail permissions. On the final line, we specify the name of our policy. The naming is important here since we'll be referencing it later when we tie this policy back to James, our website user. Now let's look at our contractor policy. This one is very similar, except that the included accounts specifies just the contractor account. Further, we have 2 different permissions, DynamoDB and Lambda. Finally, we have the DevOps policy. This one is a bit more interesting since the included accounts field contains references to both the contractor and website account. This means that this policy will be created in both accounts. The permissions for this policy are for CloudWatch. Let's pause here and try to run the Iambic CLI to create these policies. We bring up our terminal and run the Iambic plan command, and give it a path to the location of the YAML files that we just created. This is a dry run command that does a diff between what exists in our accounts and the changes that you specify locally. It gives you a preview of all the changes that it will make. You can see here that it detected 4 key changes. First, that the website policy is going to be created in the website account. Second, that the contractor policy is going to be created in the contractor account. And finally, the DevOps policy that's going to be created in both the website and contractor account. This looks like exactly what we want. We can now run the Iambic apply command using the same arguments, which will perform the actual change. Similar to plan, it gives you a confirmation step, and if you choose yes, the changes will be made. At this point, all 4 policies in my 2 accounts have successfully been created. Let's move on now to creating the user accounts. To create our users, we'll navigate to the user directory in our project. There are a couple of pre-existing users I've created in the respective accounts to give you an idea of the default file structure. In our case, we'll be creating 3 new template files for our users. We'll start by creating a directory called custom users and an initial YAML file for James, our website editor. Here, we'll drop in a document. Similar to the policy documents we created earlier, we specify the account this user is for, website in this case, the policy that they have access to, which is website policy, and the username they will be assigned. That's all we need. Let's do the same for Adriano. Adriano's template looks almost exactly the same, with only differences being the account he has access to, the policy he has assigned, and his username. There's really not much to change here. Next up is Emily, which is a bit more interesting. As you can tell, there's a lot more going on here. Emily's document references 2 different accounts, contractor and website. Under Managed Policies, we're assigning specific policies based on the account in question. For example, here we're saying that on the contractor account, Emily will receive the DevOps policy, and below it, on the website account, she will receive the same policy. Finally, the third entry grants Emily the ability to change her password for both the contractor and website account. I hope you can start to see the flexibility Iambic offers. Through these simple to assemble template files, we can compose some pretty flexible permission policies. To finish up, we'll bring up our terminal and run Iambic apply while giving the command a directory to our users. After confirming the changes, we're all done. Now all 3 users have their needed IAM accounts. We're good to go. One last thing I wanted to show you is how to expire users at a certain time. So let's go back to Adriano's template file. Assume that since Adriano is a contractor, we want to expire his account at some time in the future. To make that happen, we can place the expires at field at the top of our template file. This field supports relative and absolute values, so we can say 12 hours from now, or at a specific time like the end of the year. Now by placing expires at near the top of our template file, we're telling Iambic to expire this entire user at the provided time. However, if we place expires at under one of the managed policies, Iambic will expire just that permission and keep the user intact. This is helpful for adding temporary or short-lived permissions to a particular user. To show you how this works, let's set this to a time in the past, which is about 1 week ago from today. We can go back to our terminal and run Iambic apply, and see that the CLI automatically detects that this user should be deleted. This is a really helpful feature to help you set automatic expiry for your users. Now before we move on to how Iambic works behind the scenes, I wanted to briefly touch on some additional features. In this demo so far, we've been managing all these permissions locally using the Iambic CLI. This is great for a single user like myself, but obviously it won't scale if there's more than just one person. Iambic offers enhancements and collaboration features through GitHub integration. By setting it up, you can collaborate with your peers by adding a pull request for a new change, then getting a reviewer and relying on a GitHub workflow to perform the updates for you instead of having to run the commands yourself in the CLI. Using the GitHub flow also gives you more powerful access to automation features like drift detection, automatic rollbacks, automatic expirations, and more. GitHub integration is the recommended approach for any production use case. Now, say you're in a larger organization and need to manage many different users, all with unique and evolving permissions to a variety of different resources. For that, there's the Iambic Enterprise solution. The Enterprise version provides an easy-to-use UI where users can log in and request or renew access for certain permissions. Administrators can add custom approval workflows, configure automatic removal of unused permissions, and add virtual guardrails to alert you to risky changes. In this clip, I'm using the Enterprise solution to request an S3 policy to a certain bucket and submitting it to an administrator for approval. If you're an organization looking for a more feature-packed solution, the Enterprise solution is perfect for you. So let's jump into how Iambic works. There's 3 different angles to look at Iambic. The first through the individual user flow, the second through the GitHub flow, and the third through the Enterprise solution. We already walked through the individual user flow in the demo, but let's recap it briefly here. In this flow, everything is performed locally in the CLI. You set up the CLI, import your account or organizations into your project, modify your templates, and then run the apply command to make changes to your accounts. All updates are done on your local machine using your AWS CLI credentials. The individual user flow is the simplest of the bunch and doesn't require much further explanation. The Git flow is a little bit more interesting. Instead of running the CLI locally to perform changes, all actions are orchestrated via GitHub repository. When a user wants to submit a change, adding a new user for example, they submit a pull request to their GitHub repository. Iambic's GitHub app will automatically detect this potential change and trigger a job to run the Iambic plan command locally within my organization's management account. The diff between the current state in my account and the pull request will be compared, with the results being sent back to GitHub for review. GitHub automatically adds a comment to the pull request with the changes that will be made. When a user comes along and approves it, the change will be picked up by your management account and the apply command will be run, making all the proposed changes to the underlying accounts. Now say someone like me comes along and fumbles around in the console, bypassing the GitHub process. Say I deleted Adriano's account, for example. Iambic can automatically detect the changes made manually by listening for events that occur in my AWS accounts, and then generating a template file that reflects that change, before finally updating source control with a commit that reflects it. In other words, Iambic supports bidirectional synchronization between the state of your AWS accounts and Iambic's GitHub repository. Now say someone comes along in my AWS account and deletes a user that is currently being managed by Iambic. If the template file that manages that user has deletion protection enabled, Iambic will automatically detect a violation has occurred and reinstate that user's account. This is a form of drift prevention, which allows Iambic to detect policy violations and revert them. Now, deleting a user manually probably isn't something that you'll want to do regularly. If you use the expires at feature like we saw in the demo, Iambic's GitHub actions will trigger a job that automatically deletes the corresponding user, role, or policy when the target time is hit. To summarize the Git or the CI/CD flow, it allows you to collaborate with users to propose and automatically apply changes. Actions that take place outside of Iambic can be synchronized with your source control, and actions that require future tasks will be automatically applied to your accounts when the time is right. Finally, let's briefly talk about the third flow, which is for enterprise. This flow builds on top of everything we've spoken about already. The one distinction is the Iambic UI. Users interact with the UI to request or renew access to certain permissions they need. Administrators can set up predetermined templates that users can select from and approve requests as necessary. The Iambic UI still uses your GitHub repository as the source of truth for the current state of your organization. Requests made via the UI are brokered through a SaaS app that holds additional state and communicates with GitHub on your behalf. The enterprise solution is much more suitable for larger organizations that have many users that need to request access to a variety of different resources. So that's Iambic. If you enjoyed what you saw, then you can give Iambic a try absolutely free at iambic.org. And you can reach out to the team for access to their enterprise solution if you think that's something that's right for you. Thanks so much, and I'll see you in the next one.